We thought we had it all figured out. The universe began with a bang 13.8 billion years ago, stars slowly formed, galaxies gradually assembled, and black holes grew over billions of years by feeding on matter and merging together. Simple, clean, textbook cosmology. But James Webb just found something that breaks every rule in that book. Naked black holes, monster black holes weighing tens of millions of suns floating in the cosmic void just 700 million years after the Big Bang. Black holes so massive, so ancient, and so impossibly mature that they have no right to exist. And they're not alone. There are hundreds of them. Scientists are calling them the little red dots, mysterious crimson specks scattered across Webb's deep field images. For 2 years, astronomers argued about what they were seeing: ancient galaxies, dying stars, dust clouds. But in August 2024, the verdict came in. They're black holes, supermassive black holes, and they've just rewritten the origin story of our universe. Because if these black holes are real, and they are, then something is fundamentally wrong with the Big Bang. Either time itself worked differently in the early universe, or these monsters were born another way entirely, a way that challenges everything we thought we knew about cosmic creation. The discovery started quietly. Webb was scanning a region of space called Pandora's Cluster, using the cluster's gravity as a cosmic magnifying glass to peer even deeper into time. That's when researchers spotted it, a solitary object glowing in infrared light, not surrounded by stars, not embedded in a galaxy, just there, alone, massive, ancient. They called it QSO-1. A naked black hole weighing 50 million times the mass of our sun, observed when the universe was barely 750 million years old. Here's why that's impossible. According to every model we have, black holes form when massive stars collapse and explode as supernovas. These stellar black holes weigh maybe 10 to 100 times the mass of the sun. To grow into a supermassive monster like QSO-1, they'd need to gobble up gas, merge with other black holes, and gradually bulk up over billions of years. But QSO-1 didn't have billions of years. The universe itself was only 750 million years old when Webb photographed it. That's like finding a fully grown adult elephant when the world is only 3 days old. The math doesn't work, the timeline doesn't work, the physics doesn't work. And QSO-1 isn't some weird outlier. Webb has now identified over 300 of these little red dots, hundreds of impossibly massive black holes scattered throughout the infant universe, each one defying the laws of cosmic evolution.
Let's break down exactly how broken our cosmology has become. For decades, scientists believed they understood black hole formation. It went like this. First, stars form. Some of those stars are massive enough to collapse into black holes when they die. Those black holes then sit at the centers of forming galaxies and slowly grow by eating surrounding matter. Over billions of years, through countless meals and mergers, they become the supermassive black holes we see today in galaxies like our Milky Way. This process is governed by something called the Eddington limit. It's the maximum rate at which a black hole can feed. Push matter in too fast, and the radiation pressure from all that infalling material actually blows the food away. It's like trying to drink from a fire hose. There's a speed limit to how quickly black holes can grow. Scientists calculated that even if a black hole started forming immediately after the Big Bang and fed at the maximum possible rate for 750 million years, it could only reach about 10 million solar masses, maybe 20 million if everything went perfectly. But Webb found QSO-1 at 50 million solar masses, and it's not even the biggest. Some of these early black holes tip the scales at hundreds of millions of solar masses. They're too big, too fast, too early. Roberto Maiolino from Cambridge University, who led the team that confirmed QSO-1's nature, put it bluntly. This is completely off the scale. It's terribly exciting, but also terrifying, because it means we fundamentally misunderstand something about the early universe. The crisis deepens when you look at the galaxies these black holes should be living in.
In the modern universe, supermassive black holes always sit at the centers of galaxies. They're like the hub of a cosmic wheel, with billions of stars orbiting around them. The black hole's mass is typically about 0.1% of the galaxy's total mass. It's a delicate cosmic balance. But QSO-1? Its host galaxy barely exists. The black hole makes up 10% of the total mass, not 0.1%. 10%. That's like finding a human brain that weighs more than the entire torso. The proportions are all wrong. And here's the kicker. The host galaxy shows almost no metals. In astronomy, metals are any element heavier than hydrogen and helium. Metals come from stars that lived, fused elements in their cores, and then exploded, spreading those elements into space. The lack of metals means this galaxy hasn't experienced many stellar generations. It hasn't had time for stars to form, live, die, and create the raw materials for new stars. So how did a black hole this massive form in a galaxy that's barely had any star formation? Scientists are being forced to consider something once thought impossible, that maybe these black holes didn't form from stars at all. Maybe they were born another way. And that's where things get really wild. When your observations shatter your theories, you have two choices. Either your observations are wrong or your theories are wrong. Webb's instruments have been recalibrated, cross-checked, and verified. The observations are solid, which means the theories have to change. Enter the primordial black holes. Back in 1971, Stephen Hawking proposed something radical. What if black holes didn't need stars to form? What if some black holes were born directly from the Big Bang itself? In the first fraction of a second after the Big Bang, the universe was unimaginably dense. Tiny quantum fluctuations in that primordial soup could have caused pockets of matter to become so compressed that they collapsed directly into black holes. Not stellar black holes from dying stars, but primordial black holes born in the chaos of creation itself. For decades, this idea sat on the sidelines. It was interesting theoretically, but seemed unnecessary. We had a perfectly good explanation for black holes. Stars die, black holes form. End of story. But now, primordial black holes might be the only way to explain what Webb is seeing. If millions of tiny black holes formed in the first moments after the Big Bang, scattered throughout space like cosmic seeds, they could have served as gravitational anchors. Gas would fall toward them, matter would accumulate, and within hundreds of millions of years, not billions, they could grow into the supermassive monsters Webb has discovered. This solves the timeline problem. It gives black holes a head start, allowing them to reach impossible masses impossibly quickly. But it creates a new problem. If primordial black holes are real and abundant, they should be everywhere, not just in the early universe, but today. We should be detecting them. And for the most part, we're not, unless we are, and we just don't know it yet. Some scientists now suspect that primordial black holes might make up a significant fraction of dark matter, that mysterious invisible substance that comprises 85% of all matter in the universe. We've been searching for exotic particles to explain dark matter for decades and found nothing. What if dark matter isn't particles at all? What if it's ancient black holes, born in the Big Bang, scattered throughout every galaxy, silently pulling on the fabric of space? It's a stunning idea, and Webb might have just found the evidence. But there's another possibility, one even more radical. Maybe these aren't galaxies hosting black holes. Maybe there's something entirely new, a cosmic object we've never seen before. Scientists have proposed the existence of black hole stars. Imagine a gigantic star, maybe 10 million times the mass of the Sun, with a black hole trapped inside its core. The star's outer layers shine brilliantly, but at its heart, matter spirals into the black hole, releasing enormous energy. The star and the black hole exist in a strange symbiotic dance, neither fully star nor fully black hole. These black hole stars would shine red, they'd appear compact, and they'd exist only in the early universe, when conditions were different. Sound familiar? It matches exactly what Webb is seeing with the little red dots. If black hole stars are real, they solve multiple problems at once.
They explain the red color, the compactness, the enormous luminosity, and the strange proportions. They're not galaxies that grew too fast. They're an entirely new class of object that only existed at cosmic dawn. But whether the answer is primordial black holes, black hole stars, or something we haven't even imagined yet, one thing is certain. The Big Bang as we know it is under siege.
So where does this leave us? For nearly a century, the Big Bang has been the cornerstone of cosmology. Everything we understand about the universe's history rests on it. The expansion of space, the formation of elements, the birth of stars, the assembly of galaxies, it all starts with that singular moment 13.8 billion years ago when everything exploded into existence. But what if the Big Bang wasn't the clean, simple event we imagined? What if the universe didn't start with a single explosion, but with a chaotic, violent birth involving quantum fluctuations, collapsing regions, and the instant creation of millions of black holes? What if time itself worked differently in the early universe? What if the expansion rate varied? What if the laws of physics were subtly different when the cosmos was young, hot, and dense? These are the questions astronomers are now being forced to ask, and the answers could rewrite textbooks across every field of science. Consider what Webb has found in just 2 years. Galaxies that appear more mature than they should be, star formation happening 10 times faster than predicted, black holes that defy the laws of growth, structures that shouldn't exist for billions of years already assembled in the cosmic nursery. It's not just one anomaly, it's an entire pattern of impossibilities. Dale Kochevsky from Colby College put it perfectly. It's pushing the boundaries on what we think might be true, what we think might happen. And here's what makes this moment so extraordinary. We're not just finding things that are surprising, we're finding things that are impossible according to our current understanding. That's the difference between discovery and revolution. Every time a telescope has dramatically increased our ability to see the universe, it's revealed things that forced us to completely rethink our models. Galileo's telescope showed moons orbiting Jupiter, proving Earth wasn't the center of everything. Hubble showed the universe was expanding, leading to the Big Bang theory itself. And now Webb is showing us an early universe so fundamentally different from what we expected that scientists are openly discussing whether cosmology itself needs to be rebuilt from scratch. This isn't about tweaking a few numbers. This is about confronting the possibility that our origin story is wrong. The implications stretch beyond astronomy. If primordial black holes are real, they change our understanding of quantum mechanics and gravity. If the early universe had different physical laws, it changes our understanding of fundamental physics. If black hole stars exist, it changes our understanding of stellar evolution and the periodic table of elements. Some physicists are even proposing that our entire universe might be inside a black hole, that the Big Bang wasn't an explosion outward into nothing, but rather a collapse inward from a previous universe, that reality might be fractal, black holes within black holes within black holes, each containing its own expanding cosmos. Sound crazy? Webb is making scientists take these ideas seriously. Right now, missions like the Nancy Grace Roman Space Telescope and Euclid are being designed to study the universe on even larger scales. They'll map billions of galaxies, trace the influence of dark energy, and search for patterns in cosmic structure that could reveal whether our universe is truly alone or part of something larger. But we don't have to wait for future missions to know one thing. The universe has sent us a message through James Webb, and that message is clear. You thought you understood me. You were wrong. The monsters Webb has found lurking in the infant universe aren't just anomalies, they're evidence. Evidence that the cosmos is stranger, more complex, and more mysterious than our equations allowed. We've spent the past century building a tidy story about how everything began. Stars formed, galaxies assembled, black holes grew, nice and neat. But the universe doesn't do neat. It does chaos and creation on scales we can barely comprehend. And now, for the first time, we have the technology to see that chaos directly. Every time we think we've reached the limits of cosmic strangeness, the universe reminds us we've barely scratched the surface. These impossible black holes aren't just rewriting astronomy textbooks, they're forcing us to confront a profound truth, that the story of creation is far older, far stranger, and far more beautiful than we ever imagined. And if scientists are right, if these black holes were truly born in the Big Bang itself, then every atom in your body, every star in the sky, and every galaxy stretching across billions of light years shares a common origin with these ancient monsters. We are all children of the same cosmic catastrophe, connected to these impossible black holes by 13.8 billion years of expansion and evolution. The universe isn't broken, our understanding is, and that's not a crisis, that's an invitation to imagine bigger, question deeper, and accept that the cosmos still has secrets we haven't even begun to uncover. So what do you think? Has James Webb just proven that the Big Bang needs a complete rewrite? Are primordial black holes the key to understanding dark matter? Could our entire universe be inside a black hole from a previous cosmos? Share your thoughts in the comments below. And subscribe to Cosmolife, because this story is far from over. Every week, Webb is sending back new data. Every month, scientists are proposing new theories. We're living through a scientific revolution in real time. And trust me, you don't want to miss what comes next, because once you've seen naked black holes that defy the laws of physics, once you've glimpsed the chaotic violence of cosmic dawn, once you've realized that the Big Bang itself might be more complex than anyone imagined, there's no going back. The universe has shown us its cards, and they're far wilder than we ever expected. It's too late to apologize, too late to pretend our old models still work. The evidence is here. The revolution has begun. Welcome to the new cosmology. It's going to be a wild ride.